so that we could. Okay, the recording is started. So welcome everyone. So good day to all of us uh, who is here in our uh, weekly tech training calls and meetings. So currently we are at 76 people and we're expecting a higher number in the next few minutes. But let me just get started and introduce what's the sense of everything in this case. So in the past weeks, we have conducted around 5 trainings, all related to open mapping tech and open mapping data. And I'd like to go through how the model of the training series have been going. So don't fear, and don't be scared because all of the recordings from the past trainings are available, and is being shared to everyone who's joining the call. So if you would want to go back and look at the other recordings and listen in, I'll be sharing the link where you can view the recordings and the slides that the trainers have given. So all in all, since March, we've been conducting a weekly training on several open tech tools and techniques for mapping. So we've gone through open drone imagery. We've gone through remote desktop mapping using OSM through ID, JOSM Tasking Manager, and MapSwipe for web. We're also looking at AI-assisted mapping. Last March, there are several tools that you could use for individual and coordinated mapping that you could use in the field. Last week, we did accessing and visualizing open map data using different tools, online tools. And this today, we're going to discuss introduction to basic QGIS analytics. So just a quick overview. As you can see here, that contributing to OpenStreetMap or contributing to the open mapping movement, there's several ways that you can get into this, from drone imagery to digitizing through map swipe tools, on mobile tools, etc. And there are several entry points wherein you could get in. And in some ways or another, they are all connected. That's why we've gone through from drone imagery. Now we're doing to processing, accessing, and using map data. We're going to dive into QGIS in the next 2 topics that we have. So without further ado, before we start, I would like to set up some ground rules. As you may notice, everyone is on mute right now. So if you have any questions, please do feel free to put it in the chat, and our guest speaker will be answering those as we go through the discussion. I will be moderating the question, so feel free, if you have any questions, drop it in the chat box and do that. For those who will be asking for recordings, all sessions have been recorded and will be recorded, and we will be sharing the repository of the recordings to you after on later. Um, Again, I think I've gone through all the rules. I will now pass it to our esteemed guest from Mammoth Geospatial, John Bryant, a good friend, John Bryant. Thank you, John, for allowing us to have you tonight.
All right. Thanks, Miko. Should I take it away? Am I good to go?
Yes.
Okay. All right. Well, happy Friday, everyone. And thanks a lot for spending your Friday afternoon, evening with us here. I'm here to talk about, as Miko said, an introduction to basic QGIS analytics, and talking about QGIS is one of my favorite things to do. So I'm really, really happy to be here. So I guess I'll share my screen and jump into my presentation. One moment, please. Share. Okay. All right. Can we see this? Yeah, I got a thumbs up. Okay, great. Thanks. All right. So my name's John Bryant. I am from Canada, but I'm currently based in Fremantle, Western Australia. And so I've got a company called Mammoth Geospatial. We specialize in people around the world with open source GIS. We're especially focused on QGIS, PostGIS, and GeoNode, amongst a few other open source GIS projects. So I'm really keen on open source GIS, and I'm super involved in the open geospatial community. I've been involved in starting and running local groups and events like GeoGeeks, Phos4G, State of the Map Oceania, OSG Oceania, and OpenStreetMap Fiji. And I'm currently on the board of OSG Oceania, and we're basically so that I can help work to build a strong open geospatial community across Australia, New Zealand, and the Pacific. So something I'm really keen on. And I've been doing GIS for a long time, and I first discovered QGIS around 2007. So I used QGIS alongside ArcGIS for quite a few years, but in 2017, I went all in on QGIS, and it's been a daily tool for me ever since. So in the last 2 or 3 years, I've been running a lot of QGIS training. I've done nearly 100 sessions with over 500 people, and like I said, it's just one of my favorite things to do is to share the joy of open source geospatial. So I really love open source, open data, open communities, and like I say, I'm really glad to be here with this group of people. So I want to talk a little bit about QGIS. I'm sure a lot of you are already very familiar with QGIS, but for those who might be newer to it, so what is it? Well, it's a desktop GIS for working with geospatial data and making maps. And one of the things that everybody knows about it already, but it's a really important aspect of it is it's free. So it's free, as in it doesn't cost you money, but it's also free as in freedom. So it's an open license. There are no paid tiers. You get all of QGIS for free forever. And so just a little bit about the history of QGIS. It's been around for a little over 20 years. It was invented in 2002 by a fella up in Alaska by the name of Gary Sherman. And he created it as a viewer for the PostGIS spatial database. Before that, there was no way of seeing your map objects that were in the spatial database. But he created this thing, and he shared it on a mailing list. He shared the code on the web and put it out there. And lo and behold, a lot of people found it useful and found it interesting to contribute to it. And the project kind of grew and grew and grew from there until I would say 2018 was a real major turning point when QGIS 3.0 came out. And I'd say that's when it really became ready for prime time. And so now a few years later, we've got around 2,000 contributors to the project around the world, millions of users, and this project is growing very fast. A really important point about QGIS is, I mean, much like AutoSM, much like OpenStreetMap, QGIS is powered by community. I mean, QGIS wouldn't even exist without the global community of contributors, so including developers, documentation writers, trainers, evangelists, and passionate users who actually believe in sharing and collaboration. So about what we're doing here in this session. So we're going to be talking about analytics in QGIS, but just to put in some context, I mean, why do we use GIS in humanitarian work? And there are obviously many reasons, some of which to understand human impacts of disasters, for example, to identify priority areas of work, to plan logistics. And what we're going to focus on in this session is the last one I've got there, which is understanding where the data gaps are. And so what I'm going to do here is a very quick walkthrough. I'm going to show you an analytical process where I'm using open data to identify areas in Papua New Guinea, where OpenStreetMap buildings and roads are what I would call undermapped, where there are roads, there are buildings on the ground, but they're not captured in OpenStreetMap. And so I want to look at a way we can use this open data, bring it into QGIS, and use some analytical methods to pinpoint those locations. So I'm going to start from scratch. I'm going to start with a blank canvas. I'm going to show you where I get all my data and how to run the analysis. I'm not going to get into some of the more complicated GIS fundamentals like coordinate systems or things like that, but we're going to focus on some of the techniques that we can use in QGIS. So we're going to look at where buildings and roads are mapped, and importantly, where they're not mapped, and sort of ask some questions about where do we expect them to be. I mean, I mean, we have a feeling about this. Like, we know that buildings are where people live, and people live where buildings are, right? Like, there's a strong correlation there. So we're going to explore that a little bit, and also explore how we can use analytical methods in QGIS to help us determine these mapping priorities. So I'm going to switch over to QGIS. And so I've got a blank slate here, an empty QGIS project, and I'm just going to do a little bit of setup here. So like I say, I'm going to go through this fairly quickly. I've only got a limited amount of time, so I'm probably going to go a bit fast, but since we're recording it, you can always go back and check things later if there's something I go through a little bit too quickly. And we can ask questions, and I'll try to answer as many of them as I can at the end. So the first thing I want to do is I need to get some data into my QGIS canvas. So I'm going to just bring in the OpenStreetMap base map. And like I said, I'm going to be focusing on the country of Papua New Guinea. And so I know where it is on this map. I can zoom into it, but I just want to use the locator bar down in the bottom left to show off some of QGIS's cool functionality. And using the Nominatum geocoder, I can just zoom straight into the location of that country. So while I'm here, I've kind of found a good area of interest. So I want to add a spatial bookmark just so it's easy enough for me to come back later and zoom right to that location again. Saving my project bookmarks. So now, no matter where I zoom to in the world, I can always just double click on that spatial bookmark and it'll bring me right back to Papua New Guinea. Okay, so I've got my OpenStreetMap base map. I'd like to get another base map here. I want an aerial photo because what I'm going to be doing is zooming in and out and looking for buildings and roads to sort of confirm my analyses. So I'm going to use a plugin called Quick Map Services. So I'm just going to load that in from the QGIS repository. Quick Map Services. I'll install that plugin. And then in that plugin, I need to install the contributed pack as well so that I can get a good aerial photo base map. And so I'm going to use the Bing satellite base map. Okay, so now I've got a aerial photo base map. One more thing I want to add here is a national boundary for Papua New Guinea. And so there are many different places I could go to get this, but I know one place I could get it from is straight from OpenStreetMap. So there's a plugin I like to use for getting OpenStreetMap data from the OSM database, and that's called Quick OSM. So Quick OSM. So I'm just going to install that plugin. Waiting. There we go. Okay, so now I've got a new toolbar. And this one allows me to download OpenStreetMap data direct from the database. So I'll just open up that dialog. Yes, I understand the copyrights. And so yeah, I can use this dialog to query the OSM database. And what I'm looking for is an admin level, a feature with an admin level key, and the value of it. I just happen to know that the admin level for national boundaries is 2. And the extent of my search is Papua New Guinea. Okay, and just a couple more things I need to set in here. So I only want the polygon boundary, so I'll turn off line strings, lines, and points. And since I'm downloading it, I want to hang on to it. I'm going to save it into a new geo package. So I'll save that to that location. Then I can run my query. And hopefully this is nice and quick. There we go. Cool. All right. So I've got a new level in my QGIS project here. That's the PNG national boundary, including maritime areas. And I'm just going to open up the layer styling panel and change the styling of that. I'll just give it, I think I'm going to give it an inverted polygon style, and I'll just change that simple fill color to white and make it semi-transparent. So it kind of highlights, within that inverted polygon, highlights our area of interest. Okay, one more layer to add to set up here, and that is, so like what I've loaded here is the national boundary, including the maritime boundaries, but a lot of the analysis we're going to be doing is going to be based on land areas. So I want to load a polygon layer that constitutes those land areas for this country. And so I'm going to use a data source. So I've just got a few data sources for data that I'm going to use in this demo here. And I'm just going to show you each of them, introduce them as I bring them in. So this is the, many of you will probably be familiar with this one. This is the GADM. This is the Global Administrative Boundary Database. And this one includes administrative boundaries at all kinds of levels. So one thing I'll point out here, the data, this is the sort of license information. So always good to check the license for the data you're using. Freely available for academic use, other non-commercial use, which I think this fits. So I'm going to take a look at downloading the spatial data by country. And so I can see here, it's got it in various formats, and it's got level 0, level 1, level 2. So this is the GADM. This is the next layer I'm going to bring in, and I've already loaded it. I've already downloaded it to my machine, so I'll just grab it from here. So I downloaded level 0, 1, and 2. And the one I'm at after the national level 1 is, I believe, level 0. There we go. So now I can see I've got just the land areas there. And if I switch over to OpenStreetMap, maybe I make this just a outline, or at least make it very, very transparent. Maybe I'll it up a bit. Okay, so yeah, if I zoom in now, I can see the boundary of the edges of that that polygon boundary match the OpenStreetMap base very, very well at most scales, and certainly at the scales that we'll be looking at here today. Okay. What else here? I think I'm going to just group these two base maps together because OpenStreetMap being satellite, I'm never going to really want to have them both on at the same time. So I'm just going to group them together, call it base, and I'll make that a mutually exclusive group, which just kind of makes it easy to sort of toggle back and forth between the two with a single click. All right. So yeah, so into the analysis, I want to start actually looking at some analytical data here. So the first sets of data I want to take a look at are population related, and so there I have 3 different data sets I want to take a look at, and they're all coming from the Humanitarian Data Exchange. Again, I imagine many of you will be familiar with HDX. It's an incredible source of data, over 20,000 data sets available. Many of them are geospatial, so you can use them in your GIS. And so I'm just going to head to the data page here. And so, like I said, I've got 3 that I want to take a look at, but I'm gonna bring up the first 2. Well, I'll bring them up one at a time, and we'll go through them one at a time. But the first 2 are coming from an organization called WorldPop. So I'm just going to filter this down to the WorldPop organization. You can see they've got 1,081 data sets, so quite a bit. And I'm just going to narrow that down a little bit further to just the ones that are relevant to Papua New Guinea. Enter. Okay. All right. So I've got the 2 that I'm interested in from WorldPop are actually right up at the top here. And the first one I want to take a look at is this modeled population estimates for Papua New Guinea. And so this one is a vector layer. This is a vector polygon layer. And what it is, I'll wait for this to come up here. There will be an interactive map opening in a moment. But you can see down below, these are the downloadable assets, and the one I'm after here is this zip file here, which says it contains the estimates of total population. And so as we can see here, it comes with an interactive map, and I can see that these are local administrative areas with population numbers associated with them. So perfect. This is exactly what I want to get my hands on to begin with. I've already downloaded it. And this one I've got here in the HDX folder under WorldPop. And that's these 3 data sets here. So we've got them at 3 different jurisdictional levels. We've got province, district, and LLG. And so LLG is local level government. That's those are the smallest administrative boundaries that they've got data for, and those are the ones that I want to use for this. So that's dragged it into there. So I need to bring that up here, and then I can see. I'll just turn some other stuff off here. So yeah, so now I can see we've got this vector layer in QGIS. I know it's a vector layer because I can select features. And I can also use the Identify Features tool to select a feature and get information about it. So if I select random LLG, I can see that, well, it has a few attributes in it. It's got a name, area in square kilometers, and total, which is the total population of that particular LLG. So as I can click through a few of them, I can see they've got different totals. So these are the population numbers that I'm going to use to begin with. So this is kind of like an exploratory analysis to begin with. I just want to kind of get a feel for what my data looks like, the contents of the data, what it means. And so the first thing I'm going to do is work on the layer styling a little bit, so I can actually sort of see the patterns. And so by default, when I bring a vector layer into QGIS, it's rendered with a single symbol renderer, but I'm going to change that to a graduated renderer. And I'm going to render it based on the value of the total attribute. So if I just hit classify there, I'll get my first look at the distribution of the population around the country. And so the higher population is the darker red. I'm going to make a couple of little changes here just to sort of get down into the details a little bit. I'm going to increase the number of classes from 5 to 10. So I can get a little bit more of a breakdown. I might change change the color ramp, try a different color. So I'll try this Viridis color. Okay. So it's starting to get a little bit more of a sense of where the population centers are in the country. But when I look at it, so the capital of Papua New Guinea, Port Moresby, is down here, and this is one of the more densely populated parts of the country. And if I look at the colors of those polygons, so the highest population is not really necessarily popping up into these polygons, and that's because these are relatively small areas. So we've got, like, it is densely populated, yes, but the subunits, the smaller administrative suburban units don't have such a high population because of the size of them. So a better way to visualize the population of the country might be to use population density. So a few different ways we could go about doing this, but I want to take a look at a nice, quick, and easy way to do it, which is I don't have to create any new data, I don't have to find any new data, but because we know that the area in square kilometers is actually currently captured as an attribute in this data set, I can just divide the population by the area, and I'll get a population, a value for population density. And so I can just, in fact, add that directly into this value section here. So normally it's just you pick one of the attributes, but you can also write an expression in here. So I'm just going to write a quick expression. So it'll be the value of the total attribute, divided by the value of the area kilometers squared attribute. If I click OK and then classify, we see we get a new quite a different visualization here. And this is much more we've got these relatively large populations in these relatively small areas really jump out down in Port Moresby. And also we can see where some of the other more densely populated parts of the country are. So up here in the center of the country and a few areas along the coast. Okay, so we've got our first data set. We've had a little bit of a look at it. Let's move on to another data set. So the second world pop data set I want to look at is this Papua New Guinea population counts. This one, oh, actually I'm going to go back. I'm going to open that in a new tab because we'll be coming back here. So this one is a little bit different. This one, as it says here, it's a gridded data set. We'll see what that means in a sec. And if I go to the external site for this one down at the bottom, it tells me a little bit more about the data. So it takes me to the World Pop data, World Pop website, which is the original source of the data. A little bit of a look at what the data will look like when we get on the map, and also, as it says here, estimated total number of people per grid cell. So let's remember that, total number of people per grid cell. Okay, so let's head back over to QGIS and bring in that data layer. So that would be this one here, this PNG PPP 2020. I'd bring that into the map canvas. I'll turn a couple of other things off here. You can just look at that in isolation. Maybe I'll leave the base on. So this one's quite different. Where the last one we looked at was a vector layer with distinct polygon features. This time we're looking at a raster layer, and this one's quite a different type of data. This one's actually, if we zoom in, we can see it's just kind of more like a continuous surface with these pixels in it. And we can, so rather than having distinct features with attributes, in a raster layer we have distinct pixels with a value, in this case a single value, because it's a single band raster. But because in here in the website it said estimated total number of people per grid cell, so what we're looking at here is each grid cell has a value against it, and this is the total number of people thought to be living in that grid cell. And so this is kind of an interesting format of data. We can take a look at in the legend, in the layers panel on the left here, we can see the minimum maximum values. So the lowest value pixel is 0.004 people. Obviously, this is kind of like this is a model, and this sort of like stretches the concept of people across the landscape. But so we can see 0.004 at the bottom and 15 people per pixel up at the top. And so the lighter ones in color have a higher value. The darker ones in color have a lower value. But we can change these colors around a bit, and we'll do that in a second. Another thing I wanted to point out here was if we click on these areas where there's water, so these are no data values, and that basically because there's nobody living on water. So it makes sense. So I want to change the style for this layer. And so a little bit different from the vector styling. This is a raster layer, so this layer styling panel looks a little bit different. So by default, that's come in as a single band gray raster. I'm going to change that to a single band pseudo color raster. And I need to give it a color ramp. I'm going to use spectral. Now we can see, so it's got a range of colors. Rather than going black to white, it's going from red to blue and various colors in between. I'm just going to invert that color ramp so that the red ones are actually the high values. We can see it down here in Port Moresby. Those are the highest value pixels. Yep. And one thing, so I mean, as I kind of look across the whole country, it's a little bit difficult to really see the nuance in this sort of area. or out here where there's a lower population, you can't really see much of anything at all. Like you can sort of just get a vague sense that there's a bit of a population high there. So I just want to quickly show you how we can adjust that. I'm going to turn on the raster toolbar. And there's a button on the raster toolbar. Let's pop that out here for a sec. It's a button on the raster toolbar on the far left, which is a local stretch, which means if I sort of zoom into a layer and I hit on the local stretch button, what it does is it readjusts the minimum maximum values in the legend to use just the pixels that it can see locally within the map extent. And so if I want to adjust to sort of bring out the nuance in a specific area, I can just zoom into it and hit on that restretch button for that area. And it may or may not work across the country, but probably if I zoom into sort of this kind of area, click on that, I can get something, yeah, that's fairly decent. So now I can see, I'll just get that out of the way. Now I can see, again, across the country, what sort of the general population distribution is. Okay. What else?
John,
Yeah,
before you proceed, I think
yeah,
this is one interesting question that Baron shared.
for sure.
What version of QGIS are you using?
Yeah, well, 3.36 for me. I'm on the latest version, but there's a long-term release right now is 3.34. So I always recommend that people either stick to the latest long-term release or the current latest release, and it's always worth keeping those up to date because there are always bug fixes, security fixes, and things to keep in mind.
Thank you, John.
Yeah, no worries. Okay, so I would like to just take a quick look at these pixels. So I was clicking on the pixels to get sort of the values of them. I also want to take a look at the size of these pixels. So if I use the measure tool on the toolbar, I can actually get a bit of a sense. Maybe I'll find, yeah, so I can get a sense of how big these pixels are. So the value of the pixel is 0.307 people living in that pixel, and the size of the pixel is not about 90 meters on a side. So just for reference, give us a little bit of the sense. So that means there are 0.307 people living within that 90 meter by 90 meter square. Very theoretical construct, but yeah, this is what we're dealing with when we're talking about this particular national population data set. So any other thing I wanted to point out there was, whereas with the vector data, all of these polygons are different sizes, and so we had to modify the we had to get a population density value. We had to normalize the raw population number by the area. In the raster data, is quite different because every pixel is the same size, so we don't need to do that normalization. It's actually kind of normalized by default. The population density is actually built in. Okay. All right. Okay, so we've got two data sets, two population data sets in our project. Just do a very quick little back and forth between them. I can see they seem to correlate very well. That's great. I want to bring in a third population data set. And so the third one is, just bring this back over. Okay, so the third one is, this is a global raster data set that's divided up into countries. And this one, if I look in the data series filter box over on the side here, I can see there's this one here called Data for Good at Meta, high resolution population density maps and demographic estimates. This is the data series that I want to take a look at. Again, I'm just going to filter that down to Papua New Guinea. Okay, and so here's the data set that I'm interested in. I'm going to click on that and head to the data page. And so I can see here claiming to be the world's most accurate population data sets. This sounds really promising. Several maps and data sets. And the one that I'm going to use for this exercise is this PNG General 2020 GeoTIFF. So again, it's a raster data set. One thing I'll just mention here that I found, so it says it's 31 megabytes as a zip file, which is great, no problem, I can download that. When I unzipped it, it unzipped to 20 gigabytes, and it was really, really, really slow to use in QGIS. So I just wanted to share a tip that might make your life easier. If you do download it and you unzip it and it's slow to work in QGIS, you're struggling with it, if you just run these two commands using GDAL, which comes installed with QGIS. If you're on Windows, you can use the OSGeo4W shell, and you can just run these two lines of code on that. It'll take a minute to process that data, but it'll output a new layer, a new GeoTIFF that will work a lot better in QGIS, and it's only 40 megabytes instead of 20 gigabytes. So highly recommend taking that approach if you download this data and use it directly. So I'm going to bring that layer in. I've got that one here. So this is PNG General 2020. Now, so interestingly, it's quite different from the other raster. It's still a raster. We've got this sort of giveaway legend that makes it look like a raster layer. It's got the little raster icon there. But when I look at it, it doesn't sort of have that continuous coverage across the country. And if I zoom in, and take a closer look at it, what I can see is it's only got pixels where they've actually decided that people are living. And so that means that whereas in the world pop one, the only no data pixels were on water, in the meta one, the no data pixels are basically everywhere except where they've detected a population. So another thing here is I'm just going to reclassify that using a single band pseudo color, so it's a little bit easier to distinguish. And I'm going to see if I can find a spot here where I can show this. Yeah, this works. So if you notice, it's a continuous legend. So we're basically, the raster is being classified so that every pixel will have a different color based on its numeric value. But what we see here is there are basically just a few discrete values. And so if I click on pixels here, I can see 10.109. These are all 10.109, these ones here. And these blue ones here, these are all 36.73. So they've sort of got this interesting pattern in this data set where they've decided that the density is such over in this area, but when you head over to this side, it's a slightly different density. So they have basically within this pixel there are 36 people. Within this pixel there are 10 people. So there's a bit of density built into this. Kind of an interesting data set, but yeah, quite different in nature from the other one we're looking at. Oh, and another thing to look at here is these pixel sizes. So if I look at see if I can find a good spot to compare them. Yeah, perfect. So where the world pop raster, these are 90 meter pixels. These meta ones are 30 meter pixels, so it's a much finer resolution, which potentially means we're going to get more fine grain data. And yeah, so anyway, just a couple of differences between those two things. Okay. All right. So I kind of want to do a bit of comparison between these data sets. It's kind of easy to compare the first two we loaded because they both cover the entire country. I'll just close these panels over here so we can see the whole thing. Because they cover the whole country, so you can kind of just turn them on and off and very quickly and easily see, yeah, they sort of line up. We're seeing roughly the same pattern, and yeah, easy enough to get a quick visual comparison of those two things. With the meta one, on the other hand, very difficult to actually do at that scale because when we're zoomed way out, we can barely see it. So I want to take a look at some analytical approaches we can use to directly compare these populations for specific geographies. So QGIS can calculate statistics for, hang on, I'll just rearrange this. Maybe, oh yeah, I'll render this at about 50% opacity so I can see through it, maybe a little less. So, for example, I have this vector layer, which I've dragged up to the top now, has a population value, 110,000 in this case. And the raster layer is quite different in its nature. It's got all these little pixels that have their own discrete values. But what we can do is we can actually overlay these two data sets, and we can basically collect all of the pixels that fall within that polygon, and we can add up their values. So all of these little 1, 2, 3 values. So for all those thousands of pixels that fit in there, we can add all of those values together and come up with a total population for that polygon. And so in that way, we can compare the total value that's in the attribute table with the value of all those pixels combined. So I want to do this using a tool in QGIS called zonal statistics. And first, I want to introduce, if you're not familiar with it already, there's a toolbox, the processing toolbox. And this toolbox has hundreds and hundreds of amazing tools in it. So this is basically all the back-end functionality of QGIS is embedded in these tools. And the one that I'm after is called, it's in the raster analysis section, and it's called, this one down at the bottom here, zonal statistics. So I'm going to run the zonal statistics tool. And what I would like to do is, so as it says here, it calculates statistics of a raster layer for each feature of an overlapping polygon vector layer. So the vector layer is my gamma Gaussian LLG layer here. My raster layer is going to be my, I'm going to do this twice. I'm going to do this once for the world pop raster, and I'm going to do it once for the meta raster. And so first I'll do it for the PPP 2020, which is the world pop raster. I'm just going to give the column, what it's going to do is it's going to append a new attribute into the attribute table. And so I just want to give that attribute a prefix of pop, world pop, just to differentiate it from the next one I'll do. And then statistics to calculate. I just want to add up the sum of all the pixels within that polygon. So I'm just going to turn off count and mean. All I need is that sum. And then the last thing I'm going to do here is where it says create temporary layer. I have the choice. I can either create a temporary layer in QGIS's memory, which is just a temporary thing that then I can throw away later, or I can save it to a shapefile or a geopackage or what have you. So at this point, I know I'm just going to use this layer temporarily, so I'm just going to leave it as temporary layer. And I'll click on run, and it'll run that analysis. So I'll just take a few seconds. So again, just gathering up all those pixels for each of the polygons in that LLG layer, adding up all the values, and appending them to a new column in the output layer. Okay. Oh, great question. What happens to the pixel if it falls along the boundary of the layer? My guess would be, I'll just address that one. So my guess would be if it's more, like if the very center of the pixel is more on the side of this polygon, then it'll fall on that one, and vice versa. That'd be my guess, but I have not actually tested that thoroughly. Okay, so we've got a new layer here, zonal statistics. Okay, it looks a lot like the gamma Gaussian one did when we brought it in here. But if I open up the attribute table, I can see it's got all of the same attributes as we had before, plus this one new one here. And I can see it's kind of in the same ballpark in this case, and in probably a few of the cases. Got 53,000 some odd in the world pop sum, and 50, well, I did. I've resorted it now, so they're going off a little bit, but so we can see a little bit of a range here, some agreement in the world pop sum and the total columns, some disagreement, but we're going to explore that a bit more in a sec. So put that aside for the moment, because I want to run that zonal statistics again using this new layer as my polygon layer. So that's the zonal statistics layer. And as for my raster layer, I want to use that general 2020. This is the meta raster. So this one, I'm going to go pop, meta, and again, just going to stick to the sum. This time I want to save it to a geo package. So I'm just going to call, I'm actually going to create a bunch of layers in this analysis, and I'm going to put them all into one geo package, but I haven't created the geo package yet, so I'm going to do it in this step. So I'm going to call this, I'm just going to call it analysis. I'm going to call my output layer LLG pop estimates, because it's going to contain those population estimates from 3 different sources. Okay. So that looks good. I'll run that. A little bit faster than the last one because it has fewer data pixels to deal with, I think. When that's finished, cool. That looks good. Okay, so just check my attribute table, and great. So I've got my total column, my world pop column, my meta column. So just while I'm in here, I'm just going to hide a few of these columns just so it makes it a little bit easier to compare. Okay, and so now I can see roughly what the values are for each of these, the comparative values between these three. So we were just visualizing before. Now we've actually got some numbers to compare. So if I sort it by one of the columns, I can kind of take a look at. So we've got quite a bit of variability in the sum of the population values here. Kind of work my way through the data set a little bit. I can get a bit more of a feel for it. Oh, the meta one looks closer to the total. This one looks quite a bit off. But I mean, keeping in mind that at this point, we don't really know which one is correct. So we don't really know what our baseline is. Okay. All right, so just a bit of cleanup. I'll get rid of that zonal statistics layer. I no longer need that. It's redundant. And I'll take a quick look at styling this layer based on the new values that we've got. So if I do graduated renderer based on, so first I'll do it based on total. Then I want to do it based on...
John?
Yes.
Yeah, before you proceed, so that we might miss the topic, I think Tyron asked, like, if the pixel falls along a boundary of your vector layer when you're doing the zonal statistic, will it consider the pixel into the count, or will it exclude the pixel?
Yes. So I mean, I sort of addressed it, but I didn't see the full question there. But yeah, so I don't think it will exclude it. I think what it will do is if it falls on the boundary, it'll go to the side of the polygon that it's more on. So like basically the center of the pixel will be on either one side or the other. If it's right out at the edge, then same, it'll be either inside or outside. If it's outside, it won't pick it up. So I think it's basically where the center of the pixel falls.
Thank you, John. Yeah, please proceed.
Okay. Okay, so I've done a quick, very quick rendering of the total population. That's just one of the columns. I can just do the same thing for the world pop sum column, slightly different. And again, for the meta column, and again, slightly different. And so just using my, my history here in the layer styling panel, I can just toggle back through those three options and just kind of visually get a bit of a feel for the variability between these three data sets. That's a little bit of a bug there, I think. Okay. So I can see, yeah, so there's definitely some variability, but I mean, my first impression is that the one that's based on total, which is this one, and the one that's based on meta, they kind of look more similar to each other than this middle one, the world pop raster. Okay, so this is just me kind of like getting to know my data, getting a bit of a feel for the variability between these data sets. Okay, so again, that's all like a very visual way of getting a feel for these data sets. I want to take a quick look at a slightly more analytical method for doing this. And so I want to take a look at another plugin called Data Plotly. Data Plotly is used for making plots, creating charts and graphs. And when that's loaded, it creates a new button on the toolbar. This is my button here. And with that, so this opens the Data Plotly doc. And so I can choose from a few different types of plots here. So I'm going to stick with scatter plot for the moment, because I basically just, what I want to do is get a feel for the comparative distribution of the values in this table. So I want to know how the values of total compare to world pop and the values of total compare to meta. And I want to see this in a graph form rather than on a map or in a table. So my layer is this new one, LLG pop estimates. First, I'm going to compare total against world pop. And so that one, I'm just going to make this marker a little bit smaller. And I think that's good. If I just hit create plot, it'll open that up as a nice little scatter chart there, scatter plot. And I can see sort of what is the distribution of these points. How does the value of the total column agree with the value of the world pop sum column? And so if these were both perfect data sets, if we had 100% agreement with them and they were 100% accurate, what we'd expect to see is these points would be on a straight line at a 45-degree angle right up the center there, because if this data set has if this LLG has a population of 20,000 on this data set, then it should also have a population of 20,000 in this data set. So perfect agreement between two perfect data sets would be a straight line up the middle, but as we can see, there's a bit of a spread there. So it gives us a bit of a sense for the agreement between those two. I'm just going to add the other one to this graph. So I'm going to compare the meta sum one. I'll make that a different color so it stands out. And I'll just, I'm going to remove that label there just so it doesn't get too confusing. And I go create plot. So now I can see them both at the same time. And so I can see the agreement between total and world pop in blue and total and meta in this kind of hot pink here. I can also use the select here and I can see, well, if I want to see which ones these are, then it'll select, if I select them on the chart, it also selects them on the map. So I can see which ones those are that are sort of outliers. Okay, I want to see that again. Okay, I'm just kind of like, in the interest of time here, I'm not going to get too far into analytical methods, statistics, and so on. But with this data, you know, there could be many other methods you could use to determine the goodness of fit between these various data sets. But for this sort of quick exercise, I'm just going to visually take a look at this. And I kind of get the sense that the meta one actually has a better sort of goodness of fit with total than the world pop one, which sort of corroborates what I got from doing a quick visual look at the distribution of population on the map. So I'm feeling pretty comfortable with just sticking with the meta raster going forward. And so I'm going to do that. Thanks, Data Plotly. Okay. All right. So one of the advantages of raster data is that we can get more granular info at different scales. And what I mean by that is, if we think about it like this, if we have those, where's my LLG layer? So we did that roll up thing. We used the zonal statistics tool to roll up all of those pixels within that area, tally them up, and then we were able to get a value for that particular area. But we can actually do this, use the exact same method using this raster data at different scales. We can use different geographies. And so we could use larger areas like provinces, or we could use smaller areas like urban areas, or we can choose our own arbitrary geographies, like we could make a grid of polygons, for example. And in fact, that's what I want to do, is I want to create a grid of hexagons and then roll up the pixels within those hexagons and then sort of get a general, well, I'm just going to run through it and then we'll see what we're going to get. So, so the first thing I want to do there is I want to make a hex grid that covers the entire landmass of Papua New Guinea. And so to do this, I'm going to use a tool from the processing toolbox, and it is called, well, not, what is it? Vector creation, create grid. And incidentally, a lot of the tools, some of the tools, the most commonly used tools that we find in the processing toolbox are also found in places like the vector and raster menus. So this one particular, create grid, I can also find under vector research tools, create grid. And incidentally, you can also use that locator bar that I used at the very beginning and just type in the name of a tool. If you can't remember where to find it elsewhere in the interface, but you can remember the name of it, you can always just go and type it in. And it'll pop up in the list there. And whichever way you go, through the menu, the locator bar, or the processing toolbox, it's going to open up the same tool. And so what I want to do here is I want to use, so I'm going to create a grid. I'm going to create a grid of type hexagon. Rectangles would also be fine. You could do a grid of squares or diamonds. I'm going to choose hexagons because they look cool. And my grid extent, so the extent of the grid that I want to create, I want it to cover the entire landmass. So I'm going to use that GADM PNG layer to define my grid extent. And it basically just grabs the bounding box and coordinates of that layer and pops it into that extent. And then this part here is very important. So by default, it's suggesting a 1 meter spacing, which if I were to run this now, would probably be like about a billion grid cells, and it would probably take hours and hours and hours to produce. So I actually want to change that to kilometers. And I'll make that 10 kilometers in the horizontal and 10 in the vertical. I'm going to leave my grid coordinate system because I don't really want to get into coordinate systems. So I'm just going to leave that. It's fine. It'll work. And again, I'm going to create an actual layer. I'm going to save that to my geo package. And I'm going to call it something meaningful like hex grid 10 kilometer. Okay. So I think that's good. 10, 10, yep. Run that. And almost immediately I get this, this grid that covers the whole area. I'm just going to knock out the fill there just to make it a little bit easier on the eyes. There we go. That's a bit better. And the next thing I want to do to process this is I want to get rid of any of these grid cells that are outside of the landmass. So because obviously population not relevant. So what I can do is I can just use this select by location tool. I'm going to select the features from that new hex grid layer where the features not intersect, but are disjoint. So they're basically the opposite of intersect, comparing to the features from that GADM layer. And create a new selection from that. So I hit run, and it'll select all the polygons that are not touching land. So I'm just going to make that layer editable and delete those ones I've selected, clean those up. And just like that, I've got a nice grid layer that covers just the landmass of Papua New Guinea. Oh, and one more thing I'll do for cleanup here is in the attribute table. So when I did the create grid algorithm, it created all these extra columns, none of which I'm actually going to use. So I'm just going to do a bit of housekeeping and delete all of those columns. Save that. And how are we looking? Great. Okay. So the point of that was I wanted to create, like I was saying before, we were able to do the zonal statistics on the LLG polygons. Now I want to run a zonal statistics using these hex grid polygons. And I want to run it on the meta raster. So if I zoom in a little bit, just so we can see what we've got there. Yeah, so basically in this case, it's going to pull in all those pixels, add up those values, and apply a sum of those pixels to that vector polygon. So back to the zonal statistics tool. Because I just used it recently, it should be under recently used, of course. Zonal statistics. So my vector layer is the hex grid. My raster layer will be the general 2020. This is the meta one. And my prefix will be pop meta statistics to calculate. Once again, just the sum. And I want to create a temporary, or sorry, I want to create a layer in my geo package. I'm going to call this one hex pop for population. And I'll run that. So it's got quite a bit to do here. It's kind of it's basically running through thousands of polygons and probably millions of pixels, but it does it fairly quickly. And if all went well, yeah, so we've got a new hex grid layer that's got, if I look in the attributes, yeah, it's got one attribute, and that one attribute is the sum of the pixels from the raster. Yeah, so the last thing I want to do with this particular one is I'm just going to, again, apply a style, get a bit of a visual on it, graduated renderer, and yeah, that's looking pretty good. So yeah, I can get, maybe I'll actually change this around a little bit. I'm going to try a different mode instead of equal count. No, maybe I'll leave good enough alone, and we'll take a look at some other layers here. Okay. So now the fun part. So we've kind of like done a bunch of stuff with this population data. We've created some of our own population data based on the rasters. Now I want to introduce, like, basically the whole point of this was we wanted to use OpenStreetMap buildings and sort of get a feel for where OpenStreetMap buildings are undermapped. And so I want to bring in another data set from OSM. And where have I got it? There it is. If you don't know about the GeoFabric downloads, this website, download.geofabric.de, this is magnificent. It extracts every day the OpenStreetMap database and chops it into countries, subnational boundaries in some cases, and puts it in various formats so that you can use it really, really easily in GIS. So if I go down to Australia, Oceania, Papua New Guinea, what I can see here is I've got various formats, and I'm looking at shape files. This looks like what I'm after. And so I've already downloaded this. So I'm just going to bring that in. Close those ones. OSM GeoFabric. And so when you download it, unzip it, you get all these different shape files of various themes, and buildings are conveniently put into their own shapefile. So I'm just going to bring in that shapefile. Do a little bit of tidying here. What do I want to do? I want to see how these buildings relate to the population in the hex pop layer that we just created. So maybe what I need to do is change the style of that so that it's a little bit more easy to tell what's going on. Maybe I will change the mode. Yeah, that's looking a little bit better. There we go. Okay. So I guess looking again at my hex pop layer, I can see where the population centers are. Again, up in the highlands, along the north coast, and down at Port Moresby. And if I put those buildings on, I'll just make the building outlines a little bit bigger so they pop out a bit more at this scale. And as that draws, we should be able to see, so there's a pretty strong correlation between the locations of these buildings and the population centers. Oh, one more thing about these ones too, because they're from OpenStreetMap, it stands to reason that they match the OpenStreetMap base map perfectly. So vector data, OpenStreetMap base map, and yeah, they just line up perfectly, which is great. Okay, so let's see where to go from here. Oh yeah, well maybe what I'll do is I'll just add a quick label to this hex pop layer so that I can see what is the actual population for each hex. So that'll be, if I just add the layer for the pop meta sum, oh, I'm just gonna make that, I'm gonna round that because all those decimal places are hurting my eyes. It's a little bit smaller and a little bit bolder. Okay, and so now, oh, and actually I'm also gonna make that scale dependent rendering so that it doesn't, so when I zoom out, it doesn't become a sea of labels. So if I sort of zoom in and look at the pattern here, the distribution of the buildings versus the population, I can see, like I said, some pretty good agreement between them, but some anomalies too. And so like, for example, here's a couple of hex grids that have roughly similar population, 29,000, 26,000. But this one has a bunch of buildings and this one has none. So, I mean, pretty reasonable. It'd be pretty reasonable to assume that there are some buildings missing here. But we'll come back to that. Okay. So yeah, so there's the question that's coming to my mind when I'm looking at all this is, well, which areas are undermapped? I can kind of pan around and make these judgments based on looking at them. But what I want to do is actually come up with maybe a bit more of an analytical method. And so so there's obviously a strong relationship between population and buildings. People live in buildings. So how can we, so I think what we need to do here is we need to figure out what is the correlation between population and mapped buildings, and figure out what are the outliers. What are the ones that have a much lower number of buildings than we'd expect? So we need to know how many buildings there are in each of these hex grids. We know how many people live in them. We've got the numbers looking at us right there, but we need to know how many buildings. And so lo and behold, QGIS has a tool to help us count features in a polygon. Oops, wrong button. If I look in the vector analysis, I will see this count points in polygon, but these buildings are not points, they're polygons, so I need to convert them to points first. There is a tool I can use for that, which is under vector geometry centroids. So I can create a centroids data set from the OSM buildings layer. And I'm just going to save that to my geo package, and I will call it building centroids. I'll run that. This should be fairly quick. Go, 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 go. And, ooh, come on. There we go. Yeah, and so now I've got instead of a polygon layer, I've got a point layer that I can use. So I'm just going to make that look a little nicer. My centroids layer, I want to bring the size of that down. I'm just going to make them kind of like a brighter standout color. 0.1. Yeah, that looks a bit better. Okay. All right, so now that they're points, I can use that count points in polygon tool to count the points in each hex grid. Okay, oh, incidentally, I just want to point out this area up here. This is up in the East Sepik province in sort of the western part of Papua New Guinea, and this has been the subject of a big HotOSM map swipe and tasking manager campaign in the last few weeks, and so that's why we're seeing this huge cluster of buildings there. They were not there a month ago. Okay, so carrying on. So I'm gonna run the count points in polygon tool. My polygons layer is my hex grid, but which one? I want the hex pop because the hex grid does not have my population values. My hex pop does. So I want to be able to compare population to the number of buildings. So hex pop, building centroids, and I want to give, so it's going to count the number of buildings and put them in a new field called, and I'll change that to something a bit more meaningful. I'm going to call it, num buildings, and I'll save that to my geo package as, I'm going to go hex pop buildings. Okay, yep. I'll run that. And so we get another hex grid. And for this one, I want to, well, let's take a look at the attribute table first, just make sure we got what we expected. Okay, so now we know for each of those hex grids, we know what the population is, we know what the number of buildings is. And this is kind of interesting. So if I sort by population, I can see, well, actually, I'll sort by the number of buildings. I can see a lot of zeros in the number of buildings column. And in a lot of cases, that stands to reason. This is a big country with a lot of wilderness areas where we'll have very low or no population and thus no buildings. So that makes sense. But as we go up a little farther, we can see sort of as we get into some population, quite a few zero buildings still. So for some of these, we'd expect to see some buildings, but yeah, not especially mapped. And even in some areas where, so as the number of buildings increases, the population's generally increasing, but yeah, there are some areas that have a lot of people and not very many buildings. So we need to relate these two things together. I'll open those up again, actually. So we need to relate these two things together. And a nice simple way of doing that is to normalize the number of buildings by the population. So let's, I'll show you how we can add a new column to this using an expression. And I'm going to use the field calculator to do that. I've made the layer editable. I'm going to run the field calculator, and I want to create a new field. So I'm going to call this new field buildings per, and then I'm going to use 1,000 people. So buildings per 1,000 people. Make it a decimal rather than an integer. And now I need to write an expression to calculate these values. So I'm going to use the function selector here to go, so it's the number of buildings divided by per 1,000 people. So I want the population divided by 1,000, and I'm going to wrap that second part in brackets. So there's my expression to calculate this. And that looks okay. I can see in the preview, I've got a reasonable looking number, no syntax errors. So I'm going to click run on that. And that was nice and quick. So now I've got it normalized. If I sort that, auto size that. So now if I sort it from low to high, I actually see a lot of these null values, and the null values indicate that there's a population of 0. Since the 0 was in the denominator of the equation, you can't divide by 0. So those are null values. But as I scroll through, get to some zeros, yep, fair enough. We've got 0 buildings per 1,000 people. And as we move our way up, we can sort of get a bit of a feel for the normalized number of buildings in the array of grid cells. So I can do this is I can run a quick statistical summary on it using the statistical summary tool. So on the toolbar, just that sigma. And if I bring that up here and change it to hexpop buildings, I can get a feel for, well, what's the average of the average value for buildings per 1,000 people. And so I can see the mean is about 41. So across the whole country, the average, the mean value, the mean number of buildings per 1,000 people is about 41. And the median is 0, and that tells me something. That means that more than half of these grid cells are 0 or less. I'd also run that quickly on the. I'm curious to know what the population average is. So the average grid cell population is 1,360. So that tells me a little bit as well. So I just want to visualize this again. Close that. I want to visualize this layer, style it up with a graduated render so I can see where the low values are, because those are ones I'm really looking for. So if I go graduated, buildings per 1,000 people, and so a couple of things I can do here to, there we go. Turn it off, a couple of things. Okay, so just first off, I've got low to high, white to red. I actually want to reverse that because I'm thinking red are the ones, the low values are the ones I really want to highlight here. So I'll just invert that. I want to play around with these classifications a bit so I can get a more meaningful, so I can basically pull out the features that I'm more interested in. So the one thing I can do is I can change the mode again to natural breaks and give myself more classes. If I give myself like 20 classes, if I load up the number of classes, then what we can see is the classes have a sort of lower number of a smaller range each. And so I can actually turn off the ones that I'm not interested in and just turn on the very low values. And as it happens, actually a lot of the country has quite a low value of buildings per 1,000 people. So I guess where does that leave me? I've got this sense now of like where, if I think of these as being a below average number of buildings, I actually want to pull out the sort of highest priorities, the most undermapped hex cells. And so one fairly simplistic way of doing this would be to choose thresholds for buildings per 1,000 people and population, and actually knock out the ones that don't meet those thresholds. So I can do this by applying a filter to a layer. So if I've got my hexpot buildings here, let's say I only want to see the ones that have a certain size of population and have a very low buildings per population. So they kind of meet both of those criteria. So if I right click on the layer and I choose filter, I can write an expression. That expression is going to be, I want a population, well, we can use the average. So greater than or equal to the average population, which I think was 1,360 or so. So I want the grid cells that have a population over 1,360, and they have a buildings per 1,000 of, let's say fewer than 5. Fewer than 5 buildings per 1,000 would be like the really low ones, I would think. So if I write that expression, it's going to filter that layer down to just include those ones. If I test, we'll get a sense of how many that is. 597 rows. So that sounds pretty good. So what I want to do here is just change that back to a single symbol. So these are the 600 features. These are the 600 grid cells in the country that have the lowest buildings per 1,000 and a significant population. I'm just going to change the styling of that so that it's a little bit easier to see. And basically the idea here is that I should be able to zoom in to pretty much any one of these polygons and see, okay, very few buildings, population of about 6,000, but only about half a dozen buildings. If I change that to the satellite imagery, I should be able to zoom in and see a whole bunch of buildings that could be mapped. And yeah, very few of them are actually mapped. These ones here, those blocks on, but yeah, none of the rest of those are mapped. So those would be ones that could be mapped to sort of help that grid cell along. All right, how are we doing for time? Oh, we're getting a bit short on time. Okay, so I wanted to take a quick look at OSM roads. Maybe I will skip that because it's basically very similar. The idea being, I'll just sort of explain what it was going to do, but the idea being that you can bring the roads layer in from that GeoFabric download. You can do a very similar analysis based on gathering up the length of the roads that fall within each grid cell, and again, normalizing it based on population. So it'd be basically the same exercise, but instead of using points, counting points, you'd be calculating length of those lines. And that is, just to point it out in case you want to give it a shot, it's that in the vector analysis, is that sum line lengths tool will give you a result for that. But I guess basically the last thing I want to show you with this is, once you've done this, once you've identified a location, you've found an area that you think you want to map, hey, I installed this quick OSM tool. See, it's got this little, if any of you are JOSM users, you'll recognize this logo. You can just click on that and it'll take you straight into JOSM, download the OpenStreetMap data, and you can go straight into JOSM and start mapping away. So that is pretty much what I wanted to cover. I guess just in summary, so QGIS has a ton of tools and plugins to help you analyze your spatial data. You need to get to know your data, understand the source, read the metadata, check the license. The quality of the outputs is limited by the quality of the inputs and the quality of the questions you ask of them. And yeah, like basically we've really just scratched the surface of what's possible for this. If I can just make one quick plug, if that would be okay. I just want to mention, if you're doing any work in the Pacific, there's an organization called SPREP, and they've got a downloadable set of QGIS friendly OpenStreetMap extracts that gets updated on a nightly, weekly, on a regular basis, and it basically brings in all of the OpenStreetMap data into a QGIS project, sort of pre-styled. And yeah, I think that's it for my presentation. May the FOSS be with you. And I guess I think we've got a few minutes left for questions.
Okay, for everyone, I think most of the things I'm seeing in the chat are comments. Thank you very much, John, for this really great session. I was actually I actually listened very well, and I'm very much excited to practice my QGIS. So unfortunately for everyone, like, we're doing the sessions very quickly, very over the top demo sessions, because yeah, definitely this session would be so much more amazing when John is with us in person and really having that hands-on training. So I do apologize that we're really trying to squeeze what we could squeeze in this remote sessions. And I'm going to just see if there are any questions here right now. So, so someone's asking, how do we get more sessions, John?
How do we get more sessions? Yeah, well, I'll see you next Friday.
Yeah. If you want to see, I'm totally also blown away with the quality of this session, John. And maybe for everyone, if you have an idea that you want us to work on with other trainers, or even John again, feel free to answer the learner feedback form. Just message there. We want more. Please put the topic, what topics you'd be interested in. I'm going to share it again so that maybe we could brainstorm on these topics for the future. So for those who were not, while we're still waiting, for those who wants an e-certificate of this training session, please do answer our participant form. I'm also sharing that again. There you go. So that we'll be able to send you the recording and the e-certificate for this session. Any questions? Let's open the line for I think 1 to 2 minutes if it's okay. Yeah. For those, please do drop your questions in the chat, and I'm going to read it to John. So John, there's amazing chat for you that you may read in the chat box there.
Oh yeah. Do you want to just go ahead and answer questions? I mean, I
Sure.
see one at the bottom here.
Sure.
So quick question, in creating the grids hexagons, is there no need to reproject to local projection for accuracy? That's a, yeah, absolutely great question. Yeah, I think if we had another half an hour, I probably would have talked about coordinate systems for sure. The coordinate system we were using was Web Mercator, so not the most accurate, but meters based, so sort of helps get the point across. But yeah, absolutely, I would be looking at using a local projection.
Thank you, Miss Hani, for that very interesting question. So yeah, I think we have another question. Based on your knowledge, John, is there any data set with electrical grids which may be mapped the same way as roads and buildings?
I don't know off the top of my head. Electrical grids, I mean, my experience with those is usually very localized, like for one state government or something might have some, but yeah, I don't really know any off the top of my head. I would have a search through that HDX site, and there very well may be some in OpenStreetMap actually, but yeah, worth having a look at both of those.
Okay, next, one last question. Is there a plugin to analyze building footprints of different sources and compile and produce one complete building footprint?
Oh my God, I hope so, but I don't know. I don't know actually. It feels like conflating different data sets like that is can be very difficult. I've listened to some interesting podcasts from the Overture Foundation where they've talked about this problem, and I'm not aware of a plugin or a method that sort of makes it easy, unfortunately.
Okay, I think more questions are coming in. One last one, John. A hardware question. Are the plugins also available for Mac laptops? And is the
Yes.
QGIS also equally optimized in Macs as Windows?
Yes. So yeah, absolutely. So you can use QGIS and all the plugins on Mac. The plugins are all Python based, so they work perfectly well, or generally perfectly well. I have noticed a couple of exceptions here and there where there may be a bug occasionally, but by and large, yeah, the functionality and the performance are identical on all platforms.
Okay. Thank you. Okay. Just before we end this topic, I'm just going to share some announcements for everyone. Again, please do feel free to answer the participant form within the next 3 hours so that we can include you into the roster of the for the certificate. So we'll have our final tech training next week with John again. Yeah. So feel free to scan the QR code or visit us at Open Mapping Hub Asia Pacific via our social media channel. The registration page is there. And then once you sign up, we'll send you the calendar invite. Same as this one. Yeah. So we have QGIS for specific use case scenario. So we'll be diving into more tools and analysis, or yes, for specifically for land tenure, flooding, and landslide. So I hope you can join us so that you can also watch John rock the stage again. Thank you, John, again. Yeah, we're also having an introductory course on QGIS by our open mapping gurus, Rua Puka and Ponciano de Jesus. I think this is tomorrow. So if you're just starting, this might have been too advanced. Join us for tomorrow to just play around and create your first map using QGIS basics. It's in the same registration form. We also have other OpenStreetMap trainings like beginner JOSM validation training on the 20th as well, with Guru Sushma and Guru Arun. Yeah, and feel free to register in the links so that you'll be updated with the calendar invite. Lastly, we have mapathons coming in. So a while ago, we did a Papua New Guinea mapathon a few hours before this session, and we were able to map a lot of buildings in the area that John mentioned a while. As you can see, the data that we produced collaboratively immediately was accessible by John and downloadable and usable. Um, for tomorrow, or on the 21st, sorry, we'll be mapping or updating building footprints and roads in uh, island countries in Oceania that are at risk of climate change and sea level rise. So it's Vanuatu, Micronesia, and Tonga. We'll be updating the data, OSM building and road data sets for those countries. Also coastal areas in the Philippines like Dinalungan, Aurora for May 4, and in Bhutan, mountainous area in Dagapela, Bhutan. Yeah, here are the project areas for the Oceania Mapathon. So if you're not going to be available, feel free to jump into any tasking manager project and feel free to contribute. We are also open and still continuing our work. For those emergency mappers, we have the Papua New Guinea earthquake and the Taiwan earthquake. The project, feel free to look for it in the hot tasking manager. And also we have the map swipe project for Papua New Guinea. So it's more on identifying and locating the buildings before it gets digitized. So this project in map swipe eases out the tasking manager work or the digitization of building footprints by 70%. So this is very helpful. So feel free to download map swipe in your cell phones or mobile phones if you have the free time. And if you are part of any civil service organization, NGO, academe, or a group of community mappers that would like to get a free 2-hour mapathon training with any of the open mapping gurus, feel free to reach out to me. I'll drop my email address into the chat box so that we could maybe schedule this mapathon demo with your team or group. Okay, I think that's it. You can contact us via Slack in hotosm.slack.com so that you can reach out to any person from the Humanitarian OpenStreetMap team and the worldwide network of humanitarian mappers that are in this Slack channel. So if you're just starting or in advanced mode in mapping, feel free to drop by and ask questions there. We'll be more than happy to answer them. And for more questions, inquiries, etc. on these trainings, feel free to reach out to Lynn Dihont at hotosm.org or my team, Open Mapping Hub Asia.at at hotosm.org. Yes, all recordings, thank you, Ponzi. All recordings will be uploaded in this link that Ponzi shared in the chat. So it's a wiki page where on all the trainings that we mentioned from training 1, from drone training up until to next week's training with John will be uploaded there. So feel free to visit that if you have several hours of all this training time that you'd like to work on. Yes, I guess that's it. Thank you very much, John. And I look forward for the next session. I'll be your first pupil for next session and hope to see everyone again next week. Thank you, everyone. And thank you, John, again.
Thank you.